So let's just run through that again. So we're looking at covalent bonding, and we had two atoms of hydrogen, and each atom has got one electron in its first energy level. For them to become stable, they could transfer an electron, but if that happens, only one of them becomes stable, the second one doesn't. So that method doesn't work. So the way they do that is they end up sharing their electrons, so the energy levels overlap, each of them put one electron in, so they are sharing a pair of electrons. And we said that the definition for covalent bond is sharing a pair of electrons. This leads to the formation of a molecule. So we have here a hydrogen molecule. Now what I'm going to ask you to do is to try this same method of working out about sharing electrons for the questions that are on page 46 and 47. Okay, you have to draw the atoms before bonding and then after bonding. I'm going to do the first one with you, and then you can try the others, and then I'll put the answers to the other questions at the end. So the first one in your booklet is hydrogen bonding with chlorine to make hydrogen chloride. Okay, so hydrogen, if you look at the periodic table, has got one electron. I'm going to do that one with a cross. There's my hydrogen atom. And then my chlorine has got 17 electrons. So chlorine is 17 electrons, which is 2, 8, 7. And all I'm going to draw is just the electrons in the outer energy level. I'm not going to worry about the other two, just because that can make the diagram very complicated. So I'm just going to draw the 7 electrons, and I'm going to do these ones as dots. 1, 2, 3, 4, 5, 6, 7. Those are my 7 electrons. So you can see, you might think that this electron can travel across and transfer. So the hydrogen atom gives it and the chlorine takes it. But again, if it does, this will not become stable. So what they have to do is their energy levels overlap. So there's my hydrogen, there's my chlorine. Hydrogen puts its one electron into the area that it's going to share. And chlorine says, well, if you're going to put one in, I'm going to put this one in as well. So chlorine puts one in, and that means it's still got 1, 2, 3, 4, 5, 6 electrons here. 1, 2, 3, 4, 5, 6, and then the one here that it's sharing. Let's put my nucleus in each one. So you can see the way this has worked. If I cover this over, chlorine needs 8 electrons to become stable. And it's got 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen needs 2, and it's got 1, 2. So they're both stable. This is now a molecule. Here we have a molecule of hydrogen chloride, which is H bonded to Cl, and there is my covalent bond, and the covalent bond is sharing a pair of electrons. So this is my before picture, and this is my after picture with the atoms bonded together. Now I want you to do the same for each of the molecules listed, and I'm going to give you a hint and a tip. When you do methane, the formula for methane is CH4. So think about what that means. You need 4 hydrogen atoms to bond with 1 carbon. The next one is oxygen. Oxygen formula is O2. And the next one is carbon dioxide, which is CO2. And the one I missed off is water, and water is H2O. So it's 2 atoms of hydrogen, 1 atom of oxygen, and here you've got 1 atom of carbon and 2 atoms of oxygen. So for each of those now, you need to work these out. This one and this one are challenges, they're tough ones. You've got to have a really good think about it and work out how those electrons are going to work. If you need to, use some pages in your book where your notes are, and use that to help get your thinking before you draw the correct picture on your booklet. Off you go.